I have turned on the recording again because we are actually doing the problem now. Okay, so each kid would, we want to ensure that each kid would have at least one candy. Okay, so how can we change our problem, previous problem, so that each kid is ensured at least one candy, right? Actually, we can transform this problem to the previous problem, right? How? That's the thing, right? So can you tell how we can transform this to actually a previous problem? So do you see how actually it's related to the previous problem? Okay, so no answer, but let us go ahead. Well, how you can do that? Does our previous approach work here, and what should you do, right? So can we reduce this problem to previous problem? If yes, how? So let us see. Well, the big idea is like give kids at least one candy, because that's the requirement in your problem, right? Give kids at least one candy. So give it. So then how much you are left with? You are left with 15 minus 7, which is 8 candies, right? So you have given candies to each of them, right? Okay, so there are like 7 kids. So they already received one candy. Okay, so now you are left with distributing 8 candies, and then it's like a previous problem, right? 8 candies and distribute it among 7 kids. And right now you are not worried about ensuring that no kid gets because they already have one candy each. Okay, so now you are left with 8 candies, and then you can distribute it like you did it in the previous problem, right? So it can reduce to the previous problem, right? So again, this will be now, instead of 15, now it is like 8 plus 7 minus 1. Okay, and then this 7 minus 1. So this should turn out to be, unless there is a typo, this should turn out to be 3003. Okay, so some problems can be reduced to previous problem. Okay, cases like at least and so on, you ensure that the at least criteria is satisfied. So I could have changed this to at least 2 candy, right? So you could have distributed 2 to 2, and then remaining ones you distribute like assuming that there is no ordering and with repetitions. Okay, so the another question that we may ask is like now how many ways are there um, uh, that will leave some kids without any candy, right? So there are two. So we have seen two problems before. So one was 15 identical candies were there, and they have to be distributed among 7 kids. There are two cases here. One case is like there is a possibility that one kid may not receive any candy at all, and the another criteria problem was that one kid receives at least one. Each kid receives at least one candy. Okay. So one may ask a different question, like how many ways are there that will leave some kids without any candy? Okay. So in this case, you may use the previous two results, right? The first case was a very general case where it includes kids receiving one candy, at least one candy each, or it also includes cases where the kids don't, there are kids does not receive any candy at all. And then here the problem we are asking is how many ways are there that will leave some kids without any candy, right? So without any candies will be all possible distribution of candies minus the ones which ensure at least one candy. Okay, so we can use the previous two problems, and then we can subtract those combinations. Okay, so use the answer to the previous two problems. And okay, so this is the another problem that we had. How many non-negative integer numbers are there below 10,000 such that their sum is there such that the sum of the digits is equal to 9, right? So how many non-negative integer numbers are there below 10,000 such that sum of the digits is equal to 9, right? So below 10,000, right? So the things we are looking for is like 4-digit numbers. Okay, it could be 3-digit with a leading 0, right? So these are essentially 4-digit numbers. 3-digit numbers can be emulated with leading 3-digit numbers. Okay, can be emulated with this leading 0, right? And so on. 2 leading zeros can because it's like below 10,000, so it could be any digit number. Okay, so this is like a 2-digit. Okay, so what do we do here? How can we reduce this to a problem of permutation and combination, right? That's the question, right? So what are the possibilities we have? What are the possibilities we have? Okay, well, I can choose anything here, right? So I have 10 possible options between the set of digits, which is 0 to 9. So I have 10 options to choose from. So I have like 10 possibilities here. Okay, 10 possible ways to choose, but the problem is like there is a sum involved here, right? So sum of the digits is equal to 9. So if I choose 10 here, that puts a restriction on the choice of my second digit or the third digit or the fourth digit and so on, right? So because so if the digit that I have chosen here was, let us say, 9, then the 2 is ruled out, okay, or even 1 is ruled out, okay, for this position. So there seems to be a dependency problem here. My first choice is easy enough to choose because I have 10 options, but second choices implicitly depend on what was chosen in the first one, because the sum has to be equal to 9. Okay, so depending on what I choose here, so if it was 7, okay, then then the numbers that may be ruled out. Okay, so okay, one was not ruled out here. Okay, sorry. So one was not ruled out here because sum will be 10 and remaining can be 0. Okay, so this, oh, okay, so this is not a thing. So only 2 was ruled out here, but if I choose 7 here, then possible things that are left for me are, I could have chosen 3, I could have chosen 2, I could have chosen 1, I could have chosen 0. So there were 4 possibilities left for the second thing. So this looks quite tricky in some sense, right? Because first choice affects the second digit choice and so on. So how do you transform this problem into a problem that you know, right? So that's the question. How do you transform this problem into existing problem? Because we cannot keep getting into formulas, right? At some point, we have the base formulas, those 4 cases, and after that we have to use some our own ways to reduce it into problem that we know, right? So this is the problem we have in hand, right? So if you don't practice enough, you may not be able to solve such problems, right? So the tricks to such problem is usually comes with 1 or 2 insights, and then you are done, right? I want to convert this problem into a distribution problem, right? So the ways I distribute things. So I know that there are like 9 choices in the digit places. Okay, so so like can I reduce this problem into a problem where I'm just distributing objects? It could be identical objects, and so it could be like objects with repetitions and so on, and then I transform this into one of those problems. Okay, so this is more or less the hint I give you. Now let us look into the concrete things. So this is something I already told. Okay, so there are 4 options to fail. That is clear because it's like 4 digit or less, like leading 0 will make it third digit and so on. Okay, so there are 4 digits so sum of the digits must be 9. So what we can do is that we can start with all zeros. Okay, now what are we trying to, so if we start with all zeros, then what are we trying to do here? Actually the things that we are allowed to is that it can go up to 9, right? The only thing is like how many ways I can increase these zeros up to 9, right? So in some sense, I'm asking like I need several of these ones, because these ones will help me increase these items to 9 and so on, right? So and another thing is that the sum of the digits is equal to 9, right? So so the question is like now I am allowed to put 9 of these ones, right? In these places, if I can put 9 of these ones, then I'm done, right? So it's like distributing 9 ones in 4 places, right? So this is like identical things. This becomes now very familiar, right? So this becomes a familiar question. So how many ways we can distribute 9 ones in 4 places? Okay. Obviously, multiple ones can go into one go to at least one of the 4 places and get added. Okay, so this belongs to the problem of unordered with repetitions. So we can plug it into the formula, again the salad type problem or the candy problem. Okay, so this is similar to that. Okay, so I'm running out of time. If I don't stop, then the video gets split like it happened in the last time. So I'm going to stop here. Okay, we had some issues. We will look into that. Okay, but one thing I want to be sure is that I want to use Microsoft Forms because I want to keep things in one place. Okay, so let us discuss offline. Okay, I'm going to stop it now. Okay, thanks.